So I'm going to start history today, right? As we all know that history is the study of rulers, right? And wars, victories, defeats, etc., etc. It is not exactly that. History teaches us how the life evolves through the various ages in the past, right? It may be the political domain of life, it may be the cultural domain of life, it may be the social domain of life, it may be the economic domain of life, or it may be the various environmental disasters which have took place in the past. So the study of all that makes the history, right? So you can say today's lecture will be more related with the science than with the history, right? Than with the past, you can say. Because we know that when we study history, then it becomes very much important to determine the chronology of the history. So our first lecture will be that how the chronology of history is actually determined, right? So that is our first lecture today, which is an important lecture according to my opinion, right? So as we have seen uh, that we can say, as we see that if we take the this, you can say, timeline, right? If we take this timeline like this, right? So as far as the history of India is concerned, right? So we can take a certain, you can say, right, thresholds in between, right? We can take certain thresholds in between, right? So actually on the basis of the sources available to study the history, right? We can divide the history into three parts, right? On the basis of availability of sources to study the history, right? It can be divided into three parts. Right? It can be divided into three parts, right? The three parts into which it can be divided, right? One is called the prehistory. One is called the prehistory, right? And second is called the proto-history. Proto-history, right? And third period is called the history. Actually, third part is called the history. Third segment is called the history. Right? Is called the history. Right. So this is on the basis of how is it determined, right? So as far as the prehistory is concerned, prehistory is that part of the history when, right, it is that part of the history when no written records were there, when no written records were there, right? Or we can say the period of which no written records are available. More precisely, we can write it like that, right? The period about which no written records are available. Written records are available, right? So one is that period of the history, right? And second is the proto-history. Proto-history is, you can say, that period about which written records are there, but the script has not been deciphered, right? So that part of the history, about which written records are there, but you can say the records are not interpreted, because the script used is not decipherable. Script use is not decipherable, right? So this is the proto history, right? Means written records तो हैं, but जो उसमें उन्होंने स्क्रिप्ट यूज की है लिखने के लिए, वो समझ नहीं आ रही, वो कौन सी स्क्रिप्ट है, क्या लिखा है, उसको कोई पढ़ने वाला नहीं, right? So that is called the proto history, right? And as far as the history is concerned, right, so we can say that period about which the written records are there, and whatever is written is decipherable, right? So that is, so we can say the history, it is that part, right? That part of the history, right? That part of the past, you can say, that is better to say, right? That part of the past, right, about which written records are available, about which written records are there, and those are decipherable also, right? Those are decipherable also. So that is called the history, right? So it means if we take here the mainly, if I take here the sources, right? Sources can be divided into two categories, right? One is you can say non-written sources, right? Non-written, right? And the second is the written sources, written records are there, right? Written records, right? And where we try to know the past only on the basis of the non-written, you can say, sources, that is called the prehistory, right? Where we try to know the past only on the basis of the non-written sources, that is called the prehistory, right? And second thing is written records, right? So written records are there, but some records are written in such a, you can say, script, that those are not decipherable. Those are not decipherable. उनको हम पढ़ नहीं सकते क्या लिखा है, समझ नहीं सकते क्या लिखा है. And second is those that are decipherable, right? Those that are decipherable, right? And this part of the past about which records are there, but what is written, that is not decipherable, that is called the proto history, right? And this part where the written records are there and that is decipherable also, that is called the history, right? So as far as India is concerned, right? We can take here, you can say 2-3. Yes, I am coming, Nishant. We can take here 2-3, you can say watershed lines, right? 300 BCE. One is 3000 BCE. And second is, we can say 1700 BCE, right? 1700 BCE, right? And third is beyond that, right? So as far as this is concerned, which is called the 3000 BCE, right? So this is basically the, you can say, proto-history of India, because this is basically, sorry, the prehistory of India, because for this period, no written records are available, right? And as far as we can say, this is concerned between 3000 to 1700 BCE, right? So this is basically the proto-history. This is the period of Indus Valley civilization in our country, right? So this is the period of proto-history, right? Proto-history. And the period after the Indus Valley civilization, which is the Rig Vedic period, right? So that becomes the history. So history starts after the Indus Valley civilization, right? The past before that is known as the proto-history during the Indus Valley civilization, and before the Indus Valley civilization, that is called the prehistory. So this is the, you can say, main or basic thing about this. Okay, so is it clear up to this point?
Yes,
So,
sir.
Yes, sir.
Yes, sir.
okay, okay. Yes, Nishank, what is your question, beta?
Sir, I was just wondering how matlab, historians decipher these particular scripts.
Hmm. Yes, beta, basically, they try to, you can say, decipher on the basis of various linkages and relationships, right? Let's suppose let's suppose one article, right, on which something is written, and that is visible to us, right? And what is written there, right? And you can say there is some other type of articles, right? And they you can say try to establish the connections between that, right? So this is the commonness between this, right? Beta, just we do the coding and decoding, you know.
Yes, sir, I got it.
Yes, yes. So beta, it is basically that way, right? So this is, I can say, the 1700 BCE, BCE, right? So 1700 BCE. So right, and this, and beyond this, there is the period of history, history. Right? So it is in this way that we determine. So now this is the very basic thing, right? So history of India, I'm just, I have written about that, right? Periods. History of India, right? So this is the, so now the next point, which is important here, that is the, first we will talk about the sources of the history, right? So first we will talk about the various sources of the history, right? So as far as the sources are concerned, you all know that sources of history. You know, as far as the sources are concerned, we can divide the sources into two broad categories, right? Into two broad categories. One category can be known as the, we can say, one category can be known as the, you can say, right, archaeological, right, archaeological sources, archaeological sources. One category, we can say that, that is archaeological sources, right? And the second category, we can say, that is the geological sources. Archaeological sources and geological sources, we can take these two major sources of the history, right? So archaeological sources as well as the geological sources, right? So as far as the archaeological sources are concerned, right, in this, we try to, you can say, determine the history on the basis of various archaeological excavations which are done, right? In this, we can say the history is determined, or the chronology of history is determined on the basis of, on the basis of various archaeological right? Various archaeological, we can say, excavations, right? On the basis of various archaeological excavations, we determine it on the basis of that. History is determined on the basis of various archaeological excavations, right? And on this, if we take the geological sources with us, in this part, we can say history is determined on the basis of history is determined on the basis of, right? On the basis of, we can say history is determined on the basis of study of rocks, on the basis of study of rocks and the composition of the rocks, right? Study of rocks, including their composition, their age, etc. Right? So that is the, so history is determined on the basis of the study of rocks in this category, right? History is determined on the basis of the study of rocks. So this is right. So this way, you can say we can you can say know the past, right? So as far as the archaeological sources are concerned, right, the various archaeological sources include, we can say, that is the whatever the bones and fossils available, right? Bones and fossils available, right? So this is the one thing. And second is, we can say there is a stone tools available, right? There can be bone tools available, right? Stone tools, bone tools, rock paintings can be there, right? Rock paintings can be there, and then there can be the artifacts, right? Artifacts can be there, right? There can be the artifacts, or there can be the, we can say, some writings, right? Some writings, right? Some writings also. So these are the different sources. These are the different things which can be found during the excavation of various historical sites, right? So on this basis, we determine the chronology of the history, right? And the second thing here, right? And the second thing here is the geological sources, right? So as far as the geological sources is concerned, right, here we study the age of the rocks, age of rocks, right? Composition of rocks, right? And we can say the non-mineral material, right? The non-mineral material in the rocks, right? Whatever the material is there in the rocks, we can study that also, those also, right? So on this basis, we try to determine the chronology of the history here, right? So these are the two basic sources of the history, right? So that is it. So geological sources means study of rocks, right? Study of rocks is known as geology, right? Study of rocks is known as geology, right? Or it is known as the provenance also, provenance. It is known as the provenance also, right? So this is there that how do we determine the history, right? So now, as far as the artifacts are concerned, इसको हिंदी में हम कलाकृति कहते हैं, right? So by artifacts we means the, you can say, objects that are made by person, right? Like tools or some decoration pieces. That is called the artifact, right? So this is there about the sources of the history. Is it clear up to this point?
Yes, sir.
सर जैसे इंडस वैली सिविलाइजेशन में सर वो जो मिले थे सर मतलब बर्तन वगैरह जो होते हैं उनके और टॉयज वगैरह सर कैन दे बी कॉल्ड एज आर्टिफैक्ट?
Yes, beta. Those are the artifacts basically, right? Okay. So beta, now the next thing is there. The next thing is there. We can say that here, right? So it is this. So here, let me write 3000 BC. Right. So now the important next thing is here that the question, which is important question here, that is, how is the chronology of history determined? How is the chronology of history determined? Right? How is the chronology of history determined? So this is your next important question and very big question as well, that how is the chronology of history determined? So this is an important big question here, right? So now let us, you can say, solve, let us try to find the answer of this question, that how is the chronology of history determined, right? So this is a very important and very interesting, you can say, question before us, right? So this can be, you can say, part of the science and technology also, right? So this is basically at the interjunction of, you can say, geology, right? Archaeology, anthropology, right? And this is a science, right? So there are the two important methods, two important ways or techniques to determine the, we can say, chronology of the history, right? So, so, so one technique is there that is called the, you can say, relative dating method. Relative dating method, that is the one technique there, right? And the second technique is, that is the absolute dating method. Absolute dating method, right? So this is the second technique, we can say, absolute dating method, right? So this is important, right? Try to concentrate yourself, right? Your mind at this point here, you can see what we are studying, right? So first of all, we will study about the relative dating method. That what is the relative dating method, right? So first we will study about this relative dating method. Relative dating method. So this relative dating method, right? So beta, as far as the relative dating method is concerned, right? So this method helps to determine, right? This method helps to determine, you can say, it helps to determine, right? It helps to determine the relative period of, the relative period of existence, the relative period of existence of rocks and life, the relative period of existence of rocks and life, right? So in this method, or through this method, in relative dating method, we can only determine that this particular rock is, you can say, older than other particular rock. This particular rock is younger than other particular rock, right? So we can only determine that, right? Right. So only we can say, we can determine the relative period of existence of rock and life, right? And यहाँ मैं एक और चीज लिखूंगा, not the, right, not the exact age, or we can say exact age is not determined in this. Exact age is not determined in this, right? So इसके अंदर exact age की determination नहीं होती, सिर्फ हम मान लीजिए we are comparing A and B, right? We can only say that you can say A is older than B, right? We can only say that A is older than B, right? Or we can say that B is younger than A, right? So this is only what we can determine here. But what is the exact age of A and B? That is not known, right? So this is determined on the basis of, you can say, two principles, right? So this is based on the basis of two principles, right? Principles. One is known as the, one principle is called the, we can say, principle of, right, principle of superposition. One is that which is called the principle of superposition. One is that, right? Superposition. And the second is that is called the principle of faunal succession. Principle of faunal succession. Principle of faunal succession. This is the second, you can say, principle, right? So these are the two principles on the basis of which we can determine the relative chronology of the various rocks and life on this earth. Is it clear up to this point, bit?
Yes, sir.
Yes, sir.
Okay. This is relatively new for many of the students. That is why be more attentive, right? So now we will discuss the, you can say, principle of superposition first, right? Principle of superposition, right? So as far as this principle of superposition is concerned, right, it is based on the hypothesis, right? So it is based on the hypothesis, right? It is based on the hypothesis that each layer of rock, right, that each layer of rock is older than the one, right, that is, we can say, one that is above it, right, and the younger than the one that is below it, right, that is below it, right, that is below it. So this is the principle of superposition. This is based on this particular hypothesis, right? So let's suppose, let me take this example, right? I am taking these, you can say, three, you can say, layers of rocks I am taking here, right? Let's suppose one layer of rock is this, right? One, and the other layer of rock is this. And let's suppose you can say this third layer of rock is this. Let me take it. And this is the third layer of rock. Let me take it. Right? This is the third layer of rock. Right? These are the three layers of rocks, right? Which are, you can say, lying vertically, right? Vertically. One is above the other. ये vertical line का. These are lying vertically, right? So let's suppose this is, we can say, the layer A, right? And this is the layer B, right? Let's suppose this is the layer C. And let me take this as the layer B here, right? This has the layer B here, right? So here, according to the principle of superposition, we will say that A is, you can say A is older than B and younger than C, right? We will say here that A is older than B and younger than C, right? So this is the way that how we determine the chronology of the rocks, how we determine the chronology of the life, right? Fossils which are there in the rocks found, right? Right? If a fossil is found in rock A, let's suppose, right? And rock A, let's suppose, right? Right? If a fossil of species X is lying in rock A, and a fossil of another species, let's suppose Y is lying in rock B, then we will say that this species A is, we can say, older than the species this which is Y, right? Which is lying in the Z, right? So that way we determine the, you can say, order of the rocks and order of the life on this earth, right? So this is the principle of superposition. I hope this is clear to you.
Yes,
Hello.
sir.
Yes, sir.
Yes, sir.
Okay, okay. So this is the one thing,
Uh,
right? And the second thing here is, right? The second principle that we discussed, that was the principle of faunal succession, right? Principle of faunal succession, right? Principle of faunal succession. So as far as the principle of faunal succession is concerned, right? So as far as the principle of faunal succession is concerned, right? So this principle is based on the hypothesis, right? So it is again based on another hypothesis, right? So we can say it is based on the hypothesis that it is based on the hypothesis that it is based on the hypothesis that different, right? Different faunal, right? Different faunal, we can say, species, different faunal species, right? Appear and disappear, appear and disappear at different times, at different times, at different times, right? And once a faunal, sorry, and once a, we can say, you can say faunal species, right? And once a faunal species, right? Faunal species, you can say, goes extinct, right? Goes extinct, we can say, right? It disappears, it disappears, and does not, we can say, reappear in younger rocks, and does not reappear in younger rocks, does not reappear in younger rocks, right? So this is the, does not reappear in younger rocks. So this is the principle of faunal succession, does not reappear in younger rocks, right? It means okay, there are different species, right? Let's suppose species X, species Y, species Z, right? So X, Y, Z appear at different times, right? X appear at different time, Y appear at different time, and Z appear at different time, right? And when the X got extinct, right? So you can say uh, when the X got extinct, so its fossils will be found in the rocks of that time only, right? Right. And after that, let's suppose Y appears, And when the Y appears and when Y got extinct, right? Then the fossils of Y will appear in the rocks of that age only. So that is why on this basis we can find that which species come earlier and which species come later, right? So this is the point, that how do we determine it, right? So we can say this method helps to determine, right? This method helps to determine, this method helps to determine, we can say, the relative age of rocks and fossils. The relative age of rocks and fossils. So with this we determine that, right? We determine that, right? So we take here the different ages of assemblage of fossil species, right? Uh, I'm just telling you. We take here the different ages of assemblage of we can say faunal species. Let's suppose one is this age, and let's suppose the second is this age, right? And let's suppose the third one is, you can say, this age, right? So this age, right? This age, right? So there will be certain species, right? So we can say there will be a species. Let me give this name first. This is, let's suppose, A, right? इसको हम A कहते हैं. This is A, right? And this is, let's suppose, B, right? This is, let's suppose, B. And this is, let's suppose, you can say C. इसको हम C कह लेते हैं. So like this, right? So different, we can say, different, we can say, periods of assemblage, different times of assemblage are there, right? So these are the marks, right? So let's suppose there is one species, right, which you can say appears before this A and got extinct here in A. When it comes in A, it got extinct, right? And there is, we can say, there is, let's suppose, another species, right? And this species, let's suppose, right, starts here and it got extinct when it reaches here, right? When it reaches here, right? So it means this is the particular species which is yellow, right? This species was available in this A period of time, right? But this was not available in B period of time, right? That means we can say that that this species came into existence before the A period of time, but it got extinct before the B period of time starts, before the B reference period starts, right? So this can be there, right? And the next we can take here that you can say this species, right? Let's suppose this species starts here and it got extinct by the time it reaches here, right? And let's suppose there can be another species, right? This species, let's suppose, starts here, right? Starts here and it got extinct by the time it reaches here, right? And now let us take another species, right? Let's suppose this species, you can see, starts here and it goes beyond this, right? This is another species, right? And let's suppose there is, you can say, another species, right? Which species starts here and it is still persisting, right? So on this basis, we can determine the relative age of the faunal species, right? On this basis, we can determine the relative age of the species, faunal species, right? So let me write here for your, you can say, this, right? So let me write it. So here it is that that you can say, here it is, I can say that, here I would like to say that ABC are the different ages of fossil assemblage. A, B, and C are the different ages of fossil assemblage, right? Of fossil assemblage, fossil assemblage, right? So we can say fossil specifies that, right? Sorry. So we can say faunal species, right? That are that are used to distinguish, distinguish, right? Used to distinguish. यहाँ पर हम fossils लिख देते हैं, faunal species नहीं लिखेंगे, right? Fossils of species, right? Fossils of species that are used to distinguish, we can say, one layer from the other, one layer from the other, right? One layer from the other are called index fossils. Index fossils, right? So this is one category. This can be one index fossil, right? And this can be one index fossil, right? This is another category. This can be another index fossil. This is another category. This can be another index fossil. And like this, there can be different index fossils. And on this basis, we determine the chronology of various faunal species, right, that appear on the earth in the past. Is it clear up to this point?
Yes, sir.
Yes, sir.
Okay. Okay. So beta, this is the relative dating method, right? Which we have just studied, which we have just discussed, right? And the next is with the absolute dating method, which is more important, right? Next is absolute dating method. Absolute dating method, right? So as far as the absolute dating method is concerned, beta, this method is used to determine the actual chronological. This method is used to determine the actual age, right? Is used to determine the, we can say, actual age, right? Actual age, we can say, right, of rocks, and we can say fossils, right, to determine the chronology of the history. Determine the chronology of the history, right? So हिस्ट्री की क्रोनोलॉजी को डिटरमिन करने के लिए हम एक्चुअल एज देखते हैं फॉसिल्स की, या जो रॉक्स हैं उनकी हम एक्चुअल एज देखते हैं, राइट? सो वी कैन से हियर नेक्स्ट थिंग इज that in the absolute dating method, right, the numerical age of rocks or fossils is determined, right? In this method we can say, right, the numerical age of, we can say, right, age of rocks and fossils is determined, right? इसमें हम उनकी numerical age determine करते हैं, and hence the chronology of history is made. Hence the chronology of history is made. तो इस तरीके से फिर हम हिस्ट्री की chronology बनाते हैं, and hence the chronology of history is made, right? Chronology of history is made. So this is the, right? So for this purpose, right, for this purpose we use the technique of, for this purpose the technique of technique of radiometric dating is used. For this purpose, the technique of radiometric dating is used. Right? Is it clear up to this point that what is the absolute dating method?
Yes, sir.
Yes,
So
sir.
which technique is used here? Radiometric dating. Right? Radiocarbon dating is one part of the radiometric dating, right? So I will make it clear to you next. So this is there. Right?
Yes, sir. Actually, sir, any radioactive material can be used with its proper half life, sir. फिर
Yes,
उसका जितना
yes,
हाफ लाइफ होगा उसके अकॉर्डिंग कैलकुलेट कर लेंगे.
yes. So beta, the next thing is beta. So these methods are these methods are based on the natural decay, right? Natural decay of certain elements such as carbon, potassium, right, etc. Such as carbon, potassium, etc. Right. So इन methods में हम क्या करते हैं, हम कुछ एलिमेंट्स का डिके रेट देखते हैं कि वो कैसे डिके हो रहा है, कितने टाइम में डिके हो रहा है, राइट. सो उस बेसिस पे हम मेजर करते हैं ऑन द बेसिस ऑफ द नेचुरल डिके ऑफ certain elements, right? So we can say that like we discussed previously, right, in some lecture, that the entire universe is made of the, we can say, atoms. Is it true? Hello.
Yes, sir.
Okay.
Yes.
Yes, entire universe is made of the atoms, right? Right, beta. And beta, we can say, as far as these atoms are concerned, right? So atom के अंदर एक nucleus होता है, right? In every atom there is a nucleus, right? And in nucleus beta, there are, we can say, protons and neutrons, right? In nucleus there are protons and we can say neutrons, right? So इसमें बेटा होते हैं protons and neutrons, ये जो आपका nucleus है, right? let मैं इसको ऐसे ले लेता हूँ, ठीक है. इसके अंदर होते हैं protons, let's suppose, right? And then इसके अंदर और क्या होता है, neutrons होते हैं, right? So let's suppose हम nutrients हम ये ले लेते हैं, right? इसको हम कह देते हैं कि these are the neutrons, right? Let's suppose हम ये ले लेते हैं, right? Just for the sake of understanding, for the sake of simplicity, right? These are called the neutrons, right? So I'm just taking here, right? So this is called the proton, right? So nucleus के अंदर protons होते हैं, right? And इसके अंदर कुछ फिर क्या होता है, neutrons होते हैं, right? And this is for the neutrons which I am using here, right? This is for the neutrons, right? It is there, right? And apart from that, there are, we can say, the electrons also, right? So electrons यहाँ होते हैं, right? इसके न्यूक्लियस के इर्द गिर्द चक्कर काटते हैं, रहते हैं जो इलेक्ट्रॉन्स होते हैं, right? So they are around the nucleus, right? वो यहाँ होते हैं, you can say like this, right? वो यहाँ होते हैं, right? So we can say like this, वो यहाँ होते हैं, right? So फिर क्या हो गया, इसको हम बोलेंगे कि these are the you can say what, these are the electrons, सो ये चीज मैं आपको समझाना चाहता हूँ सो दैट आपको बहुत क्लैरिटी हो जाए कि हाउ द एज इज मेजर्ड। ये आपका एक साइंस एंड टेक्नोलॉजी का टॉपिक भी है, दिस इज नॉट ओनली हिस्ट्री, राइट? सो दैट इज व्हाई, राइट, protons, neutrons and electrons, right? So we can say, let me take here further that let's suppose this is an atom, right? And in atom there you will find three things, right? In atom there you will find, you can say, three things, right? One is what you will find, that is the protons, right? And the second thing you will find, that is the, you can say, neutrons, right? And the third thing which you will find, that is the, you can say, electrons, right? So that is the electrons. So this is the third thing which you will find, right? So electrons, so these are the three things. So as far as the protons are concerned, beta, protons you can say are positively charged, right? So protons are positively charged, ये positively charged होते हैं, right? So protons are basically positively charged, right? And as far as the neutrons are concerned, right? So neutrons don't have any charge, are neutral, right? Neutral होते हैं, don't have any charge, don't have any charge, ये neutral होते हैं, इनके ऊपर कोई charge नहीं होता. And as far as the electrons are concerned, beta, electrons are negatively charged. Electrons are negatively charged, right? Are negatively charged, right? So this is the whole thing up to this point, right? So is it clear up to this point? Hello?
Yes, sir.
Okay. Okay. So this is the right, beta. So now the next point which is there. So now the next point which is there, that we can say the positive or negative charge of certain element, right? The positive or negative charge of certain element is determined on the basis of number of protons and electrons, right? Number of protons and electrons. So this is it, right? So this is on this basis that the positive or negative charge is determined, right? So there are many students with the science or engineering background or science background. So it is you can say easy for them to interpret it, right? So we can say if the number of protons is greater than the number of electrons, right? So then there will be net positive charge, right? Net positive charge. And if number of electrons is greater than the number of protons, right? So there, then we can say there will be net negative charge. There will be net negative charge. So these are the two important things which you should bear in mind, right? And number of electrons, right? Number of neutrons neutrons does not, number of neutrons does not affect the total charge, right, or the net charge. So इससे कोई इफेक्ट नहीं होता क्योंकि ये न्यूट्रल होते हैं, right? So does not affect them, right? So this is the right. So next important thing, is it clear up to this point? Okay.
Yes, sir.
Okay. So now the next thing is that better in each element, the number of protons they remain constant, right? They remain constant. Number of protons remain constant, right? While the number of neutrons or electrons may vary. Neutrons or electrons may vary, right? May vary, right? So it means we have taken here like this. You can say number of one is the number of protons, and the second is the number of electrons and neutrons, right? So यहाँ हम ये लेते हैं, one is the protons, and second हम लेते हैं neutrons and electrons, right? So as far as the protons are concerned, they remain constant. Their number is fixed, right? Their number remains fixed. Their number is fixed. Fixed means constant. It does not change, right? And beta, as far as the neutrons and electrons are concerned, right? Their number may vary. Their number is not fixed. And hence may vary, right? May vary. So वो vary कर सकता है और ये fixed रहता है. So ये चीज आपके लिए important है, right? Is it clear up to this point, बेटा? एक चीज, ठीक है? So मैं आपको बेटा एक चीज पूछ रहा हूँ so that जो नॉन साइंस बैकग्राउंड वाले हैं उनको क्लियर हो जाए.
Yes, sir. It's very much clear.
Yes. So the next point is that you can say atoms of the same element, right? But with we can say different number of neutrons, right? But with different number of neutrons are called isotopes, right? Are called isotopes. इनको हम isotopes बोलते हैं of that element, isotopes of that element. So इसको हम ये बोलते हैं isotopes of that element, right? So we can say it means the isotopes of an element, right, depends on the number of you can say neutrons, right? The isotopes of an element, right, depend on the number of neutrons, right? Neutrons, right? Because हम न्यूक्लियस पे फोकस कर रहे हैं, यहाँ इलेक्ट्रॉन्स का कोई रोल नहीं है, right? Number of neutrons, right? So we can say each isotope is identified by atomic mass, right? So remember it that each isotope is identified by atomic mass, right? So हर एक आइसोटॉप को हम, प्रत्येक आइसोटॉप को हम एटॉमिक मास से you can say identify करते हैं. So atomic mass so है is equal to number of protons plus number of neutrons. Right? So atomic mass is equal to you can see that is equal to number of protons plus number of electrons. So this is the atomic mass, right, of an element. So this is how the atomic mass is determined, right? So atomic mass is determined like this. So I hope clear up to this point.
Yes, sir.
Okay, so this
Yes,
is how
sir.
this is how the atomic mass is determined. So now I am moving further. Right. So let us take an example. Right, let us take an example. Right, for example, we can say element of carbon. Element of carbon has, we can say, right, 6 protons. Has 6 protons, but it, right, but it may have 6, 7 or 8. 6, 7 or 8 neutrons. 6, 7 or 8 neutrons, right? So ये हो सकता है, right? Or 8 neutrons. Therefore, the carbon has 3 isotopes, right? Therefore, the carbon has 3 isotopes. Right? Therefore, the carbon has 3 isotopes. Right? The carbon has 3 isotopes, right? 3 isotopes with different mass. So one is, we can say, called the carbon 12, right? Carbon 12, which is written as, we can say, 12, right? Which is written as 12. We can say, let me write here C first, right? Then we will take here, right? Which is written as 12. इसको हम ऐसा लिखते हैं, which is written as 12C. So this is written as like 12C, right? So, and similarly, there is, we can say, carbon 13, right, which is written as 13C, right? And similarly, there is a carbon 14, right, which is written as, we can say, 14C, right, which is written as 14C, right? So because 12 कहाँ से आया? 6 protons plus 6 neutrons, it becomes 12. 6 protons plus 7 neutrons, it becomes 13. 6 protons plus 8 neutrons, it becomes 14, right? So this way we can say, right, there are 3 isotopes of carbon, right? 3 isotopes of carbon, right? So the next important point here, up to this point, I hope it is clear, beta.
Yes, sir. Yes, sir.
Yes, sir.
Okay. So now the next thing is, beta, that protons are positively charged. We know that protons are positively charged, right? Positively charged. So they repulse each other. Because same charge hai. So they repulse each other. Here it is important. They repulse each other, right? So next thing is that therefore neutrons play, right? Therefore we can say neutrons play, right? Neutrons play a role to keep, we can say, repulsive protons, right? Repulsive protons apart from each other, right? Apart or away from each other, apart from each other. So that is why न्यूट्रॉन्स उनको एक दूसरे से दूर रखते हैं, right? Right? Apart from each other, right? So as long as the number of, right? As long as the number of neutrons is enough, number of neutrons is, we can say, enough to keep repulsive protons, apart, right? The nucleus will be stable, because nucleus के अंदर कोई गड़बड़ नहीं होगी. Nucleus will be stable, right? Nucleus will be stable, right? Nucleus will be stable, right? But when the number of neutrons goes, when the number of neutrons goes very much disproportionate to the number of protons, very much disproportionate number of protons to the number of protons, we can see, right? The nucleus becomes unstable. Then the nucleus becomes unstable. फिर ये nucleus unstable हो जाता है. So I hope clear up to this point. Hello.
Yes, sir.
Andy, yes, sir.
Yes,
Okay.
sir.
Okay, so now I'm moving further, right? So here I would say that you can say on this account we can say, right? So carbon 12 and carbon 13 are stable, and carbon 13 are stable, right? Whereas carbon 14, okay, isotope, right? So carbon 14 is unstable, considered unstable, because here the number of you can say neutrons is much higher, means disproportionately number जो है वो ज्यादा है, right? So this instability, so we can say this instability, right? This instability makes carbon 14, right? Radioactive. ये कार्बन 14 को रेडियोएक्टिव बना देता है, राइट? सो जहां इनस्टेबिलिटी होती है वहां रेडियोएक्टिविटी, राइट? इट मेक्स इट रेडियोएक्टिव, राइट? रेडियोएक्टिव. क्लियर अप टू दिस पॉइंट?
Yes, sir. Yes, sir.
राइट. सो नाउ
दोबारा रिपीट कर दो.
यस बेटा, कार्बन 12
दोबारा रिपीट कर.
Yes, beta, carbon 12 and 13 are stable, whereas carbon 14 is unstable because neutrons and protons का जो proportion है वो ठीक नहीं है. So that is why carbon 14 unstable है और उसकी unstability की वजह से वो radioactive है. That is the right. So next is we can say the unstable isotopes. Unstable isotopes do all what they can to become stable. Right? To do all what they can to become stable. What they can to become stable. And right? And hence they decay into other elements. And hence they decay into other elements. And hence they decay into other elements. Therefore, they decay into the other elements, right? So when they decay into other elements, we can say, right, occasionally, right, they occasionally, right, change the number of, right, they occasionally change the number of, we can say, protons, neutrons, right, or both. प्रोटॉन्स का नंबर चेंज होता है, न्यूट्रॉन्स का नंबर चेंज होता है, या दोनों का नंबर चेंज हो जाता है, राइट? सो दिस चेंज इज कॉल्ड radioactive decay, right? This change is called radioactive decay. This change को हम radioactive decay, right? This change is called radioactive decay. So clear? Should I move ahead?
Yes, sir.
Yes, sir.
Okay. So this change is called radioactive decay. So now, if we move ahead, right? So the next is that, right? The next is that on this basis, whatever we have done so far, on this basis, right? The atomic nucleus that decay, atomic nucleus that decay is, right, is called parent isotope, is called parent isotope, and the product of decay, is called daughter isotope. उसको हम राइट डॉटर आइसोटोप, राइट, डिके होने के बाद वो जो बन जाता है उसको हम डॉटर आइसोटोप, इट्स कॉल्ड डाइटर आइसोटोप, राइट? सो इट इज द, right, it is the number of, right? So we can say it is the, right, it is the number of parent and daughter isotopes, number of parents and daughter isotopes, in a sample. हम सैंपल लेते हैं तो उसमें हम ये देखते हैं पेरेंट आइसोटोप, डॉटर आइसोटोप कितने हैं इन ए सैंपल, दैट डिटरमिन द एज ऑफ एनी मटेरियल, सो इससे हम फिर किसी मटेरियल की एज को डिटरमिन कर सकते हैं, राइट, डिटरमिन कर सकते हैं, राइट? फॉर एग्जांपल हियर, for example, carbon 14 isotope, right? Isotope decays into, we can say, right, decay into, you can say, nitrogen, right, nitrogen 14 isotope, which is stable, right, which is stable. So वो stable होता है, so इस तरीके से decay होती है, right? So एक element की वो decay होके कुछ दूसरा element बन जाता है, right? So on this basis we determine the age. Is it clear up to this point? Any doubt?
Yes, sir. It's clear.
Okay. So now the next thing we can say, I would write that down, right? So this method of dating, this method of dating, this method of dating is called radiometric dating. Is called the radiometric dating. So इसको हम radiometric dating कहते हैं. तो ये आपको याद रखना. मैंने आपको मैकेनिज्म समझा दिया है कि कैसे होता है, राइट? सो दैट आपको क्लैरिटी हो जाए, आपका कॉन्फिडेंस बने, आप में मोटिवेशन आए कि ऐसे होता है ये सब, राइट? यस बेटा.
सर इससे पहले वाला पॉइंट रिपीट कर दो.
बेटा कार्बन 14 आइसोटॉप decays into nitrogen 14 isotope, right?
Sir, okay.
Decays into nitrogen 14, right? So the we can say the next is the amount of time, the amount of time we can say that it takes for half, that it takes for half of the parent isotopes, right? That half of the, we can say, parent isotope to decay into, we can say, daughter isotope. Daughter isotope is called half, we can say, cycle of an isotope. Half cycle of an isotope. तो हम किसी आइसोटॉप का हाफ साइकिल कहते हैं, राइट? सो हाफ ऑफ द पेरेंट आइसोटॉप जितनी देर में डिके होता है, राइट, डॉटर आइसोटॉप में, उसको हम कहते हैं कि दिस इज द, यू कैन से, half cycle of that isotope of that element, right? So we can say at half cycle, so at half cycle, the number of, at half cycle, the number of we can say parent and daughter isotopes are equal. Number of parent and daughter isotopes become equal. Daughter isotopes become equal. So ये बराबर हो जाते हैं, become equal, right? Okay. So the next point is that, so I'm going to delete it. Should I erase it? Okay. So the next point is that beta, which is important here. That is, we can say, if the half-life of an isotope, if the half-life of an isotope, if the half-life of an isotope is known, right, the abundance of the we can say parent and daughter, the abundance of the parent and the daughter, right, isotopes can be measured. उनको measure कर सकते हैं, can be measured, and we can say the amount of time, and the amount of time that, right, amount of time that has elapsed since, right, since the we can say since the radiocarbon, right, sorry, radiometric radiocarbon, since the radiometric clock started, can be calculated. can be calculated, right? So this is the point here. इसमें लिखा है कि अगर हमें किसी आइसोटॉप की हाफ लाइफ का पता है कितनी है, तो हम पेरेंट एंड डॉटर आइसोटोप्स को मेजर कर लेते हैं और उनकी अमाउंट कितनी है उसके बेसिस पे हम ये जान लेते हैं कि रेडियोमेट्रिक क्लॉक जब से स्टार्ट हुआ है तब से कितना समय बीत चुका है, और उससे हम उसकी एज को डिटरमिन करते हैं. Now there is one point which I think would not be clear to anybody. Radiometric clock started. We have written it, right? Is it known to anybody? Does anybody know about this?
No, sir.
Okay, Nishank, do you know about this?
सर ऐसा कुछ होता है कि 10,000 साल से पहले वाली जो चीजें हैं उसका पता नहीं लगा सकते हम इस मेथड से.
Okay, 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 okay.
सर वो शायद इसलिए होता है क्योंकि केमिकल काइनेटिक्स का जो फॉर्मूला होता है सर लॉग वाला, उसमें
okay.
शायद 10,000 के बाद नहीं जाता वो.
ओके ओके. सो ये बेटा हम लोग इसको देखते हैं कि रेडियोमेट्रिक क्लॉक क्या होता है, राइट? सो बेटा बेसिकली अगर हम कार्बन की बात करते हैं, लेट्स सपोज हम रेडियो कार्बन क्लॉक की बात करते हैं, राइट? वी ऑल नो दैट प्लांट्स, राइट, absorb carbon dioxide from the atmosphere. Is it clear to everybody now? From the atmosphere.
Yes, sir. Sir.
Plants absorb carbon dioxide.
पढ़ा था सर मैंने सर, जितना कार्बन लेते हैं सर उतना वो बना देते हैं, और सर उससे उतना सर उस मेथड में बन जाता है. लेकिन सर अगर 10,000 साल से पहले के समय में जाएंगे तो तब ऐसा नहीं हो पाया, तब ऐसा नहीं होगा. मतलब तब इतना कार्बन हो नहीं पाया.
ओके बेटा, it keeps on decaying slowly, right? ये धीरे धीरे decay होता जाता है, right? And in living plants, the you can say, right, in living plants we can say decayed carbon, right? The decayed carbon is compensated by the fresh intake, right? Is compensated by the fresh intake, right? But when a plant dies, then the fresh intake starts. The fresh intake stops, right? Fresh intake stops, and the you can say carbon 14 isotope, right? Carbon 14 isotope in plants, right? Isotope, right? Isotope in that plant, right? In that plant, right? So we can say decays slowly, right? Decays slowly and keeps on decaying, right? And keeps on decaying on continuous basis, right beta? And keeps on decaying continuously, right? So beta, it means we can say that watershed line in the life of plant, right? When the life of the plant is terminated, right? And after that, you can say the carbon which is getting decayed, that is not compensated, right? And there is the net decay of the carbon, right, which starts there. That is called the start of the radiocarbon clock, right? Start of the radiometric clock, right? So अब एक ऐसी स्टेज आ गई है कि जहां कंपेंसेशन नहीं होगी, राइट? जहां जो भी उसके अंदर है कार्बन, राइट, उसका सिर्फ बस डिके होना है, और उसका कॉन्टिन्यूसली लॉस होना है, राइट? सो बेटा जब से उसका जो कंपेंसेशन बंद हो गया, राइट, सो उस टाइम को हम कहते हैं कि रेडियो कार्बन क्लॉक हैज स्टार्टेड, राइट? अगर कार्बन नहीं, अगर वहां कोई और एलिमेंट है तो उसका क्या कहते हैं, राइट? सो कॉमन नेम इनका हो गया रेडियोमेट्रिक क्लॉक हैज स्टार्टेड. Is it clear, beta, about the
Yes,
start of the
yes, sir.
radiometry? Okay. So this is the point, right? I think Navreet has left the class or somebody else has left the class. One person has left the class. So we will. Okay. So that is why, right? So we can say this way, the right age of, you can say something, right? Something is measured. Right, bones की rocks की age हम इस basis पे measure करते हैं. Something is measured, right? It may be bone, right? It may be bone or some other material, right? Some other material. So हम इस तरीके से हम different, you can say material की जो life है, age है जो हम उसको determine करते हैं. Okay, is it clear? Is it clear?
Yes, sir. Yes, sir.
Okay. So beta, now I am coming here. Let's suppose we are taking the example of a bone, right? Because there is carbon, right? But if the bone is, right? If the bone is, we can say 70,000 years. If the bone is 70,000 years or older, right? Or older, then right? Then the amount of we can say carbon 14 isotope, carbon 14 left is you can say too small, will be too small, we can say, right? Will be too small. इसको छोड़ देते हैं. Will be too small, you can say, to measure accurately. Right? Will be too small to measure accurately, right? So we can say radiocarbon dating. So radiocarbon dating has its limitations. So radiocarbon dating has its limitations, right? Has its limitations, right? It can be used only to determine the age of things of the recent past, right? It can only be used. This is an important point for the preliminary examination, right? It can only be used, right, for determining, right, for determining the age of things, of the recent past, because means the things which are older than 70,000 years, those cannot be, their age cannot be known by the radiocarbon method, right? So that is there, right? So we can say recent past. Okay. So far much older, right? We can say far much older, for determining the age of much older things, right? For determining the age of much older things, right? For determining the age of much older things, we can say, right? There are other methods. We can say that can be used, right? There are other methods that can be used, right? So now we will make a table, and from that it will become clear to you that what are the other methods that can be used. Is it clear up to this point to everybody?
Yes, sir.
Yes, sir.
Okay, and this is a very important point of limitation of the radiocarbon dating. You must bear it in mind. This is your responsibility, beta. Okay. So
Okay,
now,
sir.
So now the next thing is there, that is the table, right? Let us make a table. As far as the table is concerned, first of all we will write here the name of a method. किसी method का name लिखते हैं हम ये कि कौन सा method है age determination का, right? So we will write here age of method. Sorry, name of method. This is the one point. And the second thing is there, that is we can say the age range of application. ये कितने समय के लिए applicable है, कौन सी age range के लिए है, age range of application, right? Age range of application. So this is there, right? So right, the next we will write here material dated. ये कौन से material के लिए suitable है, material dated, ठीक है, for which type of material does it suit, right? And next is the methodology, right? Methodology. ये टेबल बेटा सभी बना लो, निशाक आप भी बना लो बेटा, right? This will be helpful to you. Okay?
Yes sir, I am making.
Yes, yes, yes. बेटा this is important. Sometimes बहुत सारे students को habit नहीं होती ना ये बनाने की. That is why I am saying ये सभी बना के रख लो, ये सभी के लिए important है, right? So ये important है. So one is the name of method. As far as the name of method is concerned, that is the first is radiocarbon method, right? So let me take it, radiocarbon method, right? So this is the name of method first of all, right? And then age range of application, we can say it is up from 1 year old till 70,000 years, as we have discussed just now, 1 to 70,000 years, right? And as far as the material dated is concerned, it is suitable for, you can say, organic materials, aging of organic materials, right? Organic materials, we can say, right? Such as we can say, right? Such as bones, wood, right? Bones, wood हो गया, and charcoal, shells, etc. Shells, etc. Right? So this is helpful for those. So this is the, so this is the. So as far as the methodology is concerned, right? In this we measure the, we can say, radioactive decay of we can say, right? So the radioactive decay of, you can say, carbon-14 isotope, right? Carbon-14 isotope into nitrogen-14, right? Into nitrogen-14 isotope, right? Into nitrogen-14 isotope, right? It means its conversion into the, we can say, organic matter, right, after removal from the biosphere. So how much time does it take? It is on this basis that we determine the age of these things, bones, wood, charcoal, shells, etc. So this is the one method which is called the radiocarbon dating method. Is it clear?
Yes, sir. Yes, sir.
Okay. Okay.
Yes, sir.
So good. So now the second method is better. That is the KAR method, right? KAR dating method. You can write it KAR dating, right? K for what is K? K for potassium.
Potassium argon.
Yes, and AR for the argon, right? So beta basically क्या होता है इस मेथड में यूजली हम मेजर करते हैं कि decay of the right potassium isotope into the, we can say, potassium isotope into the argon isotope, right? So this method is used for articles, for you can say material which is from 1000 years to, you can say, a billion years old, right? A billion years old, right? जहाँ इतनी लाइफ है हम उसको मेजर करने के लिए इसको यूज करते हैं, right? So measure that life, right? To billion years, थाउजेंड से बिलियन ईयर्स तक पुरानी चीजों को मेजर करने के लिए हम ये यूज करते हैं। ये कौन से मटेरियल के लिए सूट करता है, राइट? सो पोटाशियम bearing minerals and glasses, this is suitable for potassium bearing, right, minerals and glasses. So this is suitable for those minerals and glasses, right? So potassium bearing minerals and glasses, we can say it is suitable for those things, right? So this is there. So next is as far as the methodology is concerned, radioactive decay of radioactive, right, decay of we can say potassium 14, right, 40K लिख देते हैं, potassium 40 isotope, right, in you can say in, right, argon 40 isotope, means they decay into the rocks and minerals, right, isotope. And sometimes हम यहाँ कैल्शियम भी लेते हैं, right? So potassium का, right, or decay of this potassium 40 isotope into, we can say the you can say calcium 40 isotope, right? So calcium 40 isotope, so that is also there, calcium 40 isotope. So this is the KAR dating method. So this is useful for these things. So हम billions of years तक चले गए हैं इस मेथड को यूज करके, राइट? उसकी लिमिटेशन थी up to 70,000 years on, right? So the next is there after the KAR method. The next is the uranium lead dating. Uranium, we can say lead, right? Uranium lead dating method. Uranium lead dating. So basically on decay, right, we can say uranium decays into thorium or it decays into the lead. So this is important to remember. So age of application is, we can say 10,000 to billion of years, right, billion of years. So ये यहाँ तक इतनी पुरानी आर्टिफैक्ट्स के लिए यूज होता है, right? So we can say, right, we can say that there is the next thing. It is used for measuring the age of uranium bearing minerals or rocks, right? Uranium bearing minerals, उनकी एज को डिटरमिन करने के लिए हम इस मेथड को यूज करते हैं, uranium bearing minerals, right? So that is there, right? So we can say in this the methodology is used. What is the methodology that is used? That is the radioactive decay of we can say uranium, right, uranium into lead, right? That is we can say decay of right, uranium, we can say 238 isotope, right, into 206, right, lead isotope, right, and we can say right? Uranium 235 isotope into we can say 207, right? Lead isotope. So this is the, so ये इसमें यूज करते हैं हम. So uranium into lead, right? इसका हाफ साइकिल देखते हैं. So is it clear, बेटा? Okay. So
Yes,
the,
sir.
okay. So the
Yes,
next,
sir.
okay, beta. So the next thing is, beta, the next thing is, you can see the next method is, that is the, you can see uranium series method. Uranium series method, right? Uranium series dating method. So that is the next method, you can say, right? So this method is used for dating of for determining the age of the material, which is from 1000 years to, we can say, 5 lakh years old, right? 5 lakh years old. So this is determined for used for determining the age of those materials, right? So this is used for dating the material, like you can say uranium bearing minerals. One is that, right? Uranium bearing minerals, right? So this is, that is the, right? And beta, apart from that, right? Uranium bearing minerals. Apart from that, that is the corals, shells. Beta, somebody's mic is on. Please off it. Corals, shells, teeth, right? Teeth, and calcium carbonate, right? Calcium carbonate. So ये इन चीजों की लाइफ की एज को मेजर करने के लिए यूज होता है, जो यूरेनियम सीरीज होता है, right? So beta, in this, the method used is, you can see, the radioactive decay of, right? Radioactive decay of, right? Radioactive decay of, you can say, 234, we can say, uranium isotope into 230, we can say, thorium isotope, right? Into 230 thorium isotope. So ये uranium series में use होता है, right? ये uranium series में use होता है, right? And the next you can say method which is there, right? The next method, that is the, we can say, right, luminescence. Luminescence, right? Luminescence method, or we can say the optical, right? Or the optical, right? Optical, we can say optically, or thermally stimulated, right? So that is there, optically or thermally stimulated, right? Optical is related to light, thermal is related to heat, right? So at optically or thermally stimulated, right? So this is used for measuring the age of, determining the age of a material, which is 1000 to, we can say, 10 lakh years old, right? 10 lakh years old, right? So this is used for that, right? 10 lakh years old. And as far as the material dated in this is, इसमें कौन सा material, that is the quartz, we can say quartz, right? Feldspar, we can say quartz, feldspar, and then stone tools, we can say, right? Stone tools, and after the stone tools, you can say there is the, right? After stone tools, there can be the pottery, etc. Pottery, etc. So इन चीजों के लिए, ऐसी चीजों के लिए, ऐसी चीजों की एज मेजर करने के लिए हम इसको यूज करते हैं, right? सो इसमें फिर जो हमारी मेथोडोलॉजी है, व्हाट इज द मेथोडोलॉजी इन दिस, राइट? एज फार द मेथोडोलॉजी इज कंसर्न वी कैन से burial, जब कोई चीज नीचे दब जाती है, burial, और वी कैन से heating age, right? Age based on, right? Heating age based on the accumulation of, based on the, we can say, right, accumulation of radiation, right? Based on the accumulation of radiation induced, we can see, right, damage to electrons, so electrons का कितना डैमेज हुआ है, right? sitting in mineral lattices, LATTICES, mineral lattices, right? so beta you can say lattices क्या होते हैं? These are the repeating 2 or 3 dimensional patterns, right, due to the arrangement of the atoms. What is lattice, right? lattice क्या होता है बेटा? किसी भी मटेरियल के अंदर एक पैटर्न होता है, राइट? जैसे किसी के अंदर क्रिस्टल्स होते हैं, है ना? जैसे आप स्टोन देख लो, राइट? स्टोन के अंदर एक पैटर्न बना होता है, राइट? सो वो क्या होता है? दैट इज द, वी कैन से, repeating, right, 2 or 3-dimensional patterns, right? Patterns due to the arrangement of atoms. Atoms की arrangement की वजह से वो जो पैटर्न बनते हैं उसको हम लेटाइसेस कहते हैं. So उन पैटर्न्स को देखते हैं, राइट? क्योंकि वो एटम्स है, एटम्स की अरेंजमेंट है, एटम्स के अंदर इलेक्ट्रॉन्स थे. सो इलेक्ट्रॉन्स का रेडिएशन की वजह से कितना डैमेज हुआ है हम उसको मेजर करते हैं, और उसकी मदद से हम इसकी जो एज डिटरमाइन करते हैं. सो बहुत सारे और मेथड हैं, लेकिन इतने हमने कर लिए हैं. So these are the various methods, right? And one more method I will discuss other than this, right? So is it clear up to here?
Yes, sir.
Yes, sir.
Okay. So now beta, now the next important thing is beta, which I would like to discuss with you, that you can say there is another method which is called magnetostratigraphy, right? There is another method, right? Another method which is called magnetostratigraphy. So this is another method, right? Stratigraphy. So what is this method? Let us know. And magnetostratigraphy, this is another method. So as far as this method is concerned, which is called the magnetostratigraphy, which is called, right? So we can say it is used for measuring the age of rocks. It is used for measuring the age of rocks, right? So इसमें हम age of rocks को measure करते हैं इस method की मदद से, right? So in the range of age कौन सी range में? In the range of, right, we can say 20,000 years से लेकर के, right, up to we can say billion of years, up to billion of years. So we measure the age of the rocks, right? So it is a, you can say it is used for dating the, it is used for dating of the sedimentary and volcanic rocks. It is used for dating of, it is used for dating of sedimentary and volcanic rocks. Used for dating of sedimentary and volcanic rocks. ये उनकी एज डिटरमिन करने के लिए हम इसको देखते हैं, राइट? सेडिमेंट्री एंड volcanic rocks. So that is there, right? So in this method, we can say you can say the age of a rock is measured. The age of a rock is measured, right? The age of a rock is measured on the basis of in change in magnetic field of the earth. Change in magnetic field of the earth. Okay, magnetic field of the earth. But here one thing very much important. I think you must be knowing that there are two poles. One is the geographical poles of the earth. Second is the magnetic poles of the earth. Do you know about this? Okay.
Magnetic pole keep on changing with time.
So beta magnetic poles keep on changing, right? And beta sometimes north and south magnetic pole swap their positions even, right? And at present beta, you can say in the 19th century, the magnetic pole which was at Canada, right? At present it has shifted towards, you can say, Siberia. In 2017, it has crossed the international date line even, right? And it has entered into, you can say, Eastern Hemisphere by crossing the that, right? So that is the right. So magnetic field, right? So here it is important that we can say, right, polarity of, right, polarity of, we can say, Earth's magnetic field, right? Earth's magnetic field, right? Field keeps on changing. Earth's magnetic field keeps on changing through the time, right? Through the time. ये बेटा चेंज होती रहती है, लेकिन किस रफ्तार से ये चेंज होती है ये फिक्स नहीं होती, राइट? किसी जमाने में ऐसा भी देखा है कि ये यू कैन से 72 मिलियन ईयर्स में ये 5 टाइम्स हुआ है स्वैप. किसी जमाने में ऐसा देखा है कि 3 मिलियन ईयर्स में भी ये 14 टाइम्स स्वैप हो गया है. सो दैट मींस इसकी जो स्पीड है दैट इज नॉट फिक्स्ड, राइट? सो दैट इज द राइट. सो the next thing is that we can say, right, here it is important to mention that we can say, right, earth is surrounded by right, earth is surrounded by a magnetic field. This is known to everyone, right? Earth is surrounded by a magnetic field, right? Surrounded by a magnetic field, right? Generated by we can say, right? So generated by magnetism in the core of the earth. Magnetism in the core of the earth, right? So earth के core के अंदर जो magnetism है उसकी वजह से ये होता है core of the earth, right? So small magnetic grains, right? Small, we can say, magnetic grain, right? Grain in rocks will you can say orient themselves right? Orient themselves to be parallel, right, in the direction, right, to be parallel in the direction of the magnetic field, in the direction of the magnetic field, pointing towards, you can say north pole, right? North magnetic pole, pointing towards north magnetic pole, right? So बेटा इसमें क्या होता है बेटा कि जो इंटीरियर है रॉक के इंटीरियर में जो अरेंजमेंट ऑफ द you can say this magnetic grains or the mineral particles, you can say, right? So that is basically, you can say, in the order of the magnetic, you can say, field of the earth at that time, right? In the order of the direction of the magnetic pole at that time when that particular rock was formed, right? So let's suppose कोई rock आज से 10,000 साल पहले बनी और आज से 10,000 साल पहले अर्थ का जो मैग्नेटिक पोल था वो कहाँ था? नॉर्थ मैग्नेटिक पोल किस डायरेक्शन में था? सो इस रॉक के अंदर जो भी यू कैन से मिनरल पार्टिकल्स है उनकी बेटा अलाइनमेंट देखेंगे हम इन दैट डायरेक्शन, वो उस डायरेक्शन में रहेगी। और जब हम फिर उसका सैंपल लेते हैं तो हम उसके पार्टिकल्स की डायरेक्शन देखते हैं और उस डायरेक्शन से हम जान लेते हैं कि ये उस समय की रॉक है जिस समय नॉर्थ मैग्नेटिक पोल के इस डायरेक्शन में था और यू कैन से आज नॉर्थ मैग्नेटिक पोल वहां से मूव होके मतलब कहाँ आ चुका है। इट मींस दिस रॉक इज दिस मच कोल्ड। सो दिस इज द वे हाउ वी डिटरमिन द, यू कैन से, दिस। इज इट ओके? इज इट ओके?
Yes, yes, sir.
Yes, sir.
Yes, sir.
Okay, so beta, now the next, let me tell you one thing only here, right? Now the next important thing is beta, at present you can say current location of the magnetic poles, right? 2020 की है ये current location of magnetic poles कहाँ है? तो वैसे आपको बता देती हैं, right? Current location of magnetic poles, right? If I take here the north magnetic pole, इसकी current location आज कहाँ है? Right, north magnetic pole, इसकी जो current location है that is 86.50 degree, 86.50, right, degree, we can say, right, north latitude, right, north latitude, and we can say, right, 100, you can say 164.04 degree, right? That is the east longitude, right? East longitude. ये आपको बताएंगे, जो नए बच्चे हैं उनको नहीं मालूम इसका longitude latitude का, ये मैं आपको फिर बताऊंगा, right? Longitude, right? And as far as its south magnetic pole is concerned, right? South magnetic pole is concerned, right? Its location at present is 64.07 degree, right? 64.07 degree, we can say south latitude, right, latitude, and right, and we can say 35.88 degree, 88 degree, right, east, we can say latitude, right, east latitude. So ये इसकी आज की
Sir, longitude east.
sorry, yes, longitude लिखना है, गलत हो गई. So longitude, thanks for pointing out. So this is the longitude, right? So ये आज की इसकी लोकेशन है जो अर्थ के मैग्नेटिक पोल की लोकेशन है, right? So magnetic pole keeps on changing, and at present the magnetic pole is shifting towards the eastern side, right, from Canada towards Siberia. In 2017 it has crossed the international date line, right, and approximately 50 to 60 किलोमीटर पर ईयर ये मूव कर जाता है, जो इसका है मूव करने का जो स्पीड है, राइट? सो दैट इज so this is the today's lecture, right? If anybody wants to ask anything, you can ask, please, right?